This next problem for review from chapter 4, we're asked to find all the roots of this fourth degree polynomial. So first off, conceptual check. There are 4 possible roots. Okay? So the way we're going to do this is using rational root theorem. Now I've done a bit of the calculations beforehand, but just to get rational root theorem under our caps, we need to find all the factors of negative 30 and all the factors of 2. Any root of this polynomial that is rational is going to have the numerator a factor of 30 and the denominator a factor of 2. So we come up with a list of potential roots, plug them in, see what happens. So the roots of 30, or I should say the factors of 30, are plus or minus 1, 2, 3, not 4, but 5, 6, let's see, 6 and 5, 3 and 10, 2 and 15, and then 30. And the roots of 2 are simple enough. They're 1 and 2. Now our potential roots is going to be a fairly long list. Somewhat long list. We're basically going to take each one of these numbers and divide them by all of the numbers in the second list. So that's plus or minus 1 and plus or minus 1/2. That's 1 divided by 1 and 1 divided by 2. Then 2 divided by 1. Then 2 divided by 2. Well, we already have that one, so we're not going to repeat it. Then 3/2, or 3 over 1, so plus or minus 3. Then plus or minus 3/2. Then 5. Then 5/2. And so on. Alright, I'm not going to do them all because the roots that we actually need reside in this list so far. And the way we would find them is we would plug each of these in using our calculator in the table. So the roots that we come up with are negative 2 and 3/2. Alright? You can keep going, but you won't find any more. So we know that there are 2 rational roots. Now we said that there are 4 roots total. So the remaining, 2 of them are rational. The remaining 2 roots are either both real, that is irrational, so something like a square root, or they are complex. The only way to get to those roots is using synthetic division. So we set up our synthetic division box, and we plug in our original. Notice that there's no x squared term, so we need a placeholder. So this is going to be 2, negative 7, 0, 29, and negative 30. And I extend this out. Now we divide by the roots, not the factors. So I could choose 3/2 or negative 2. It doesn't matter one way or the other. I'm going to just go with negative 2 first. So the 2 comes down. 2 times negative 2 is negative 4. Add them, I'll get negative 11. Negative 2 times negative 11 is 22. 22 and 0 is 22. Negative 2 times 22 is negative 44. 29 and negative 44 is negative 15. Negative 2 times negative 15 is 30. 30 and negative 30 are 0, which means by the remainder theorem that this is actually a root. So we just verified what we already knew, that this was a root. Now, the nice thing about synthetic division is that we don't have to rewrite anything. We can just keep going from where we are now. Keep in mind that this represented an x to the 4th polynomial. So 2x to the 4th minus 7x cubed, etc. This is an x to the 3rd polynomial. 2x to the 3rd minus 11x squared plus 22x minus 15. So when we do our next division, it will drop the power by 1 again. So 3/2 drop to 2. 3/2 times 2 is going to be 3. Negative 11 and 3 is negative 8. 3/2 of that is 3 times negative 4, which is negative 12. 22 and negative 12 is 10. 3/2 of that is 15, which gives me 0. So again, I'm confident that 3/2 is in fact a root. And like I said, we're decreasing in power. So this right here represents the polynomial 2x squared minus 8x plus 10. We want to find where this equals 0. We'll pull out a 2. 2 is common here. X squared minus 4x, and this looks like something I can complete the square with, so I'm going to move the 5 over to the other side, equals -5. Now half the middle term is going to be 2. Squared is 4, so I'm going to add 4 to both sides. So this gives me the perfect square x minus 2 squared. This gives me -1. Square root both sides. X minus 2 is equal to square root of -1, which is I. And I forgot my plus or minus. Plus or minus I. So my final answer is x equals 2 plus or minus I. So the 4 roots are x equals -2, x equals 3/2, x equals 2 plus I, and x equals 2 minus I. 4 roots, 4 and x to the 4th.